Alright, hi and welcome to this third video of our IoT and embedded cybersecurity tutorials. So in this video, I'll be showing you how to develop your firmware for your IoT based temperature and humidity monitoring and control system using the Raspberry Pi Pico 2W, a DHT11 sensor, the OLED relay and the passive buzzer. So the firmware basically will read temperature and humidity from a DHT11, display the values on the OLED, control a relay based on temperature threshold, and trigger a passive buzzer alarm when temperature exceeds a set limit. And later on, we would implement the IoT aspect. So for your firmware design, first you need to create a new file and upload the dependency file into Pico 2W. Bear in mind the OLED 0.96 inches requires a library, and the library name is ssd1306.py. Okay, so to get this library, you need to click on this link. Go to my GitHub link. Okay, so once you click on that link, it opens up this ssd1306.py. So what you need to do is you need to come to this point and copy raw file. Click on copy raw file. Then we're going to into our Thonny IDE. So you open your Thonny IDE if you have installed it. If not, please refer to our last video. Okay, so now that we have our Thonny IDE open, the first thing we need to do is to connect our hardware device, which we assembled in our last video. So connect your system. Okay, so click on the stop button to connect your Thonny IDE with the Pico 2 microcontroller. Alright, so it has established connection. So as you can see, the Raspberry Pi Pico folder is empty. If you cannot view this panel, go to view and click on make sure your files is ticked. If you want to see your Raspberry Pi Pico directory or your desktop directory or your Windows directory, so go to files. If I click, you can see. So maybe by default, when you open your Thonny IDE, this is what you see. But if you want to see your directories, you go to file and click on view and make sure you tick the files. Alright, so you can see, so our Raspberry Pi Pico is currently empty. So next thing is you are going to create a new file. So our step 1 says create a new file. So create a new file and we save it, Ctrl S. So you're going to save it into your Raspberry Pi Pico, okay, as ssd1306.py, ssd1306.py, and you click OK. Now you copy the codes. So go back, copy the codes from your ssd1306.py from the GitHub link, and you paste it, Ctrl V, and save it, Ctrl S. So now we've saved our ssd1306.py. So this is a library that will be used in this project. The next thing is we create a new file, new, and we can save it as IoT, Ctrl save. Again, save it on your Raspberry Pi Pico as IoT underscore device, device.py. So you save it as this name first. Later on, I'll show you how to convert it into a deployment mode. Currently, we are saving it as IoT underscore device.py because we are in our development mode. So I'll click OK. Alright, so now we go back to our slides. So we've done the step 1. We've created a new file and we've uploaded the dependency file ssd1306 into it. Then in our new file which we have created, that is the IoT underscore device, we're going to import the libraries we need into our firmware we are developing. So first we need the pin module. We need the I2C. So the pin module helps us control all the GPIO pins on our microcontroller. The I2C module helps us to communicate with our OLED because we are using the I2C protocol. And the PWM, which is pulse width modulation, helps us to generate our sound on our passive buzzer. Then we need to import time. So time helps us to create some delays in the firmware. And the DHT file, we need to import that because we need to control the DHT11. And of course, we are importing this file SSD1306, which we have saved onto the Raspberry Pi Pico. So I'm going to copy all of this quickly. So I'll copy it, Ctrl C, and paste into the Thonny IDE. Right. So first you can create a comment here. So import libraries. Okay. So I'll put it as step 1. So it guides us when we're developing our firmware. Step 1. Okay, import libraries. Okay. Now, having done that, let's go back to our slides. So next slide, which is step 3. It says initialize the hardware interfaces. Alright, so now that we have imported the libraries, we need to initialize all the hardware interfaces, that is the OLED, DH11, the relay. So what I would do is I will copy all of these codes and I would put into the Thonny IDE. So this is the step 2 on the firmware design. So we initialize the hardware interfaces. Okay, so first is the OLED, which is an I2C communication device. So you need to type in these 2 lines of code. So what this line represents is that you are using GP0 as our SDA, I2C0, which has the SCL on GP1, and it has the SDA on GP0. Okay, so this is the default frequency for the OLED device. Next, you need to set the number of pixel of the pixel. So we have 128 by 64, meaning the x-axis has 128 pixel and the y-axis has the 64 pixel. So once you've done this, the next is the DHT11. So the DHT11 is connected to GP2, remember, on our pin mapping. And next is the relay. The relay is connected to GP6. So in this case, we need to set our pin to be pin.out. Why? Because we are sending a signal from the microcontroller to control the relay. Then we can initialize this as relay.off, okay, just to switch off the relay initially. Then the next is the passive buzzer. So remember, the passive buzzer on the MakerPi Pico development kit is connected to GP18. Okay, so we are using GP18 to initialize our buzzer. Of course, we are setting it to a duty of 0, 0. So the next step is for us to initialize our threshold values. So we'll be initializing the temperature threshold value. So we're going to set our value for temperature to be 30. So this simply means once our temperature reading from our sensor exceeds 30, then we can ask it to either trigger the alarm or switch off the relay or switch on the relay. After that, we go into creating functions for each of the components. The reason why we have created functions for each of the components is to make it easy for us to troubleshoot our firmware, and this is called modular design. So first, we are designing the function to read the values of the DHT11. So you create a function called read_DHT11 using the def keyword in Python. Then we use the try and except to avoid the system crashing if it tries to read the sensor, and if there's any hardware issue, then we allow the firmware to keep running rather than crashing. So this simply means the sensor read the sensor values. From the sensor values, then take the temperature value and also take the humidity value and save it in these variables temp and and return the values of the temperature and humidity. Alright, if it's unable to read the sensor values from the hardware sensor, then it returns a none. Next is the function to display information on the OLED. So we have the def update OLED. Okay, so it's going to read the values of the temperature. It gets the values of the temperature, humidity, and relay state, and based on that, it's going to display on our OLED. So on the first line, it's going to display temperature and humidity. They are just a string. Then the next line, it will display the values of the temperature, and the next line, it will display the value of the humidity, and the next line to display the status of the relay. Next is the function for our relay control logic. Again, we create a function def control underscore relay. Then it's going to expect a value of the temperature. So the value read from the temperature will be sent into this function, and it's going to compare it with the threshold value. If it exceeds the threshold value, it's going to switch on the relay, else it will switch off the relay. Next is the passive buzzer alarm logic. Okay, so we're creating a function to help us sound an alert if our value of the temperature exceeds the threshold value. So this is the function for it. All right, last is the main control loop. So after creating all the functions, we create our main loop. All right, so first we initialize the OLED by displaying this system information, system starting. Okay, then after that, it reads the values of the DHT11. Okay, then if the temperature is not a none, that is, there is no missing values, then of course it's going to call the control relay function. Then it's going to call the buzzer alert function, which we have created, and of course it's going to call the update underscore OLED alarm function, which we created, else it will display sensor error. So this R is going to continue to run continuously. Alright, so now let's look at this aspect in the Thonny IDE. Okay, so as we can see, this is the threshold value, which is 30. Then this is where we create the function. So the first function is to read from our DHT11 sensor, like I've explained in the slides. So you type in your codes, make sure there are no mistakes. Then you add the function to display on the OLED. Then you add the function for relay control logic. Then you add the function for the passive alarm logic. Then you come to the main control. So first is to, when you use the OLED.fill, it wipes out whatever information that is currently on the OLED. Then it displays this information on line 2, and of course it shows the information. Then this is to create a delay of 2 seconds. Alright, then the main loop while true, so this is an infinite loop. As long as your Pico2W is powered, this function will continue to run indefinitely. So this, like I explained, reads the temperature and humidity values from our sensor using the read underscore DHT function we created above. So once it traces the value, as long as the temperature value is not known, that is, there's a data that has been read from the temperature sensor, it will call the function control underscore relay to control the relay, and it will get the relay state, whether it is on or off. Then of course it's going to call the buzzer alert function based on the value of the temperature. Okay, then of course it's going to call this update underscore OLED function and pass the value of the temperature, which we have read, the value of the humidity, which we have read, and the relay state into it to display on our OLED. Right, else if there was an error, if there was no value read from our DHT11 sensor, then it's going to wipe the OLED display and say sensor error. and of course display the value. So this is going to run indefinitely. So we're going to demonstrate this on the hardware itself. So having finished your firmware, the next thing you need to click on the run. So I click on run. Okay, now my hardware is working. All right. Alright, so the threshold value for the temperature is 30 degrees Celsius. So currently the hardware is running, and as you can see, it says temperature and humidity. The temperature is 29 degrees Celsius and the humidity is 27%. The relay is currently off. Why? Because our temperature value is less than our threshold. Remember, the condition is if our temperature value is equal to the threshold. You can see the relay is on now. The temperature has increased to 30. If the temperature value is equal to 30 or greater, it should switch on the relay. So the relay is on, and of course our buzzer is currently active. As you can see, the relay is on. The green light on the relay shows that the relay is on, and the buzzer is currently active, as you can see. All right, so this ends the this section of the video tutorial. So if you have learned something, if you enjoyed the tutorial and you want to learn more, please kindly like, subscribe and share with others. Thank you, and see you in our next video. Bye.